This is your heading for the afternoon, coefficient of determination. I need you to pause and think about those words and recognize the difference between them and what we did earlier. The letter R stands for coefficient of association. And I'm going to run through what we mean by association to make sure you're happy with that, and then talk about determination instead. So the word to focus on this afternoon is determination. Probably take a little while to get through the lesson, but the exercise is relatively short, so you should still have time to finish it. If you do have time to finish it, can I ask you once again, there is a Darrenet quiz online on chapter 1, and there'll be one at the end of 2D on chapter 2 as well. Remember, R was the measure of association. R squared, you may have seen R squared on your calculator screens, is what we're going to call the coefficient of determination. And why is it R squared? What does it mean? Is all coming up. So going back over R briefly, it's a measure of the strength of the association. You know that. And these are some examples here of pairs of variables which may or may not be associated. Your English score and your maths score. They may be associated, they may not. Or any of these. How do we know there's an association as opposed to no association? There's some sort of a pattern, isn't there? That's right, yeah? That's what I'm asking. So that if you plotted your English scores and your math scores for this classroom, there may or may not be a pattern. Your age and your height, there may be a pattern. Smoking and lung cancer, admittedly, also may be a pattern. Age of husband, age of wife, I think we decided there probably wasn't. I can't remember now. What about height and IQ? We haven't looked at that before. Is your height anything to do with your IQ? No, that's association, right? If there's a pattern, there's an association. But when we're looking at prediction, can one of those variables be used to predict the other, which they can on that diagram there? Because you say, if you give me a bigger score for your X value, you might be able to give me a prediction for the biggest score of the Y value. So can one variable be used to predict another? Let's go through these 5 again. I think there's only one there that could really be used to predict the other. I'm not saying which way round. What do you think? I'm not saying which is the response and which is the explanatory, but one of those could be used to predict the other. Any arguments for or against any of them? Smoking and lung cancer. So which would predict which? You could predict the amount of lung cancer from the amount of smoking. Yeah, okay. Anything else? Any other contributions to that? Age and height, up to a point. Up to a point. I mean, we had this before. I'm 4 times as old as you, but I'm not 4 times as tall. What R squared is going to do is tell you how much one variable can be predicted from the information given from the other one. So R squared will tell us how much the incidence of lung cancer is related to smoking. And so that's the difference. There's an association with all 4 out of those 5, but there's only a prediction for one of them. How does it work? Now, before we go into that, we're talking about R squared. I want to revise square roots, because if you haven't got the mathematics with square roots, we're going to have a problem. Easy one. What's 2 squared? 4. What is minus 3? Putting it in brackets deliberately. Hands up for negative 9. Hands up for 9. Could you like to check on your... You even might make a mistake if you do this on the calculator. Can you prove on your calculator what the square of negative 3 is? Now, it's not a trivial question. A lot of people still get this wrong all through their lives. Can you get your calculator to show you correctly that negative 3 squared is 9? Show me that you got negative 3 squared making 9 on a calculator. Any calculator will do. Yep. So you've got to put it in brackets. Yep. So I gave the trick away by putting it in brackets. If you try and put that into the calculator, it looks like it's the same thing. What are you going to get? You're going to get negative 9, which is wrong. Negative times negative is positive. Okay. What is negative 2.25? 2.25 squared. What is it? 5.0625. So we can do it with negative numbers as well. That's what I wanted to point out. Next question, that's meant to say, what is the square root of 9? So you're saying that you're doing the opposite of this. Square root of 3?
Square root of 9.
9. Square root of negative 3? What's the square root of 9? What's the square of negative 3? What's the square root of 9? But you just said that negative 3 squared is 9 as well. They're both 9. 3 squared is 9, negative 3 squared is 9. The square root is going backwards, so the square root of 9 is? And? Negative 3. Nine has got 2 square roots, because 3 squared is 9 and negative 3 squared is also 9. So 2 things, when you square them, make 9. So when you square root 9, you're going to get 2 things, 3 and negative 3. Square root of 4 is 2 and negative 2. Everything's got what? It's got a positive and a negative. So all that time you're going through high school and your teachers told you the square root of 9 is 3. They didn't bother telling you that it's also negative 3 because you probably didn't need it at the time. Yes. I'll show you why very soon. Why? So everybody got that? You got written down notes because you all didn't know it. Have you written down something about that? The square is not in the textbook. This is additional because I know it's needed. Squares and square roots. Square root of 9 equals, you can write it like this, plus and minus 3. The square root of 9 is plus and minus 3, which is a way of saying that it's got 2 values. That's why we needed the revision. Well, it wasn't even revision, it was new stuff. I know. We never teach it in high school for some reason, and then when you come to year 12, suddenly you need it. Every number has got 2 square roots. The calculator won't tell you that. Even the calculator doesn't tell you. So moving on, why do we need that? Because if you knew what r squared was, on your calculator you already know how to get r. Well, you know also it's on the same screen, it's r squared. It just means negative 0.7218, which is 0.52. Like already, if you put that into the calculator, if you ask the calculator what the quiz gave you what r was, and you were asked to find r squared, and you just put that in like that, you wouldn't get, you get minus that. You've got to put that into brackets to square it. Why do we need r squared is the next question. Why do we need it? I told you how to get it. Why do we need it? It's because if you multiply that by 100, make it 52%, you can then say that if r is negative 0.7 and r squared therefore is 0.52, 52% of the value of the response variable, 52% of the change in y can be explained by the change in x. Now this is where it becomes important. If the smoking and lung cancer was at an r of negative or positive 0.7, then r squared is 0.52. So, which of course begs the questions, what about the other 48%? What else causes lung cancer? Have a guess.
Asbestos?
Asbestos, yeah. Breathing smoke last week, or 2 weeks ago. Old age can to some extent cause lung cancer, because if you live long enough you're going to get some kind of a cancer. The mathematics will say from that particular pattern 52% of the change in y. So it gives you a level of confidence in your prediction. If it's only 52%, that doesn't tell you very much. It says, what about everything else? If it was 90% prediction, you'd have the confidence to use it. So that's why we need to get r squared out. Why r squared? Why do we need to square it? I think you should know the answer now if you think about it. Because we want a positive value. That's all. We've got to say, we've got to have a positive value so we can turn it into a percentage, so we square it. Don't just change the sign, we square it. Just write down that r squared coefficient of determination means that a certain percentage of the change in y can be caused by the change in x, so you can make predictions. You have 52% confidence in the prediction. You can always make a prediction from the straight line, but you've only got 52% confidence that it actually means anything. In this example, I've written at the bottom there, you already know that r values can range from 1 to -1. Well, obviously r squared values, they're only positive, they're only going to range from 0 to 1 or 0 to 100%. That's just so you can't have anything outside that range in case you come across it. Is that starting to make a bit of sense? Any questions about where this all fits together? Now, this is where you need to know what the square root of a number is. If I told you that this graph had an r squared, I just told you r squared of 0.52, and you wanted to find out what r was going backwards, is it going to be this one or this one for that graph? I said to you, look, r squared on a set of data is 0.52. What's r? You say, I want to see a picture of the graph because I want to know whether it's going that way or that way. So going from r squared to r, you need a picture of the data to determine whether it's r is positive or negative. You have to look at the scatter plot. So well done if you spotted that. That is in the textbook, I hope. Certainly there's some questions in the exercise on that. And that's it. You can now calculate and interpret the coefficient of determination. And there are just 3 questions on page 41. As your first ones, if you haven't got a book. This question here, just turn them into a percentage, or square them and then turn them into a percentage. You're given r squared, what will r be? Square root it, positive or negative? Positive or negative? Okay, that's what I've just been talking about. So questions 1, 2, first of all.